Let's look at an example that demonstrates the kind of thinking needed in order to work with trees. This function, countPaths, takes in a tree and some total. We're assuming the tree has labels that are numbers, and it returns the number of paths from the root to any node in the tree for which the labels along the path sum to the total. Here's an example tree, and if we count the paths that sum to 3 or 4 or 5 or 6 or 7, we get different numbers because different paths have different sums. I think the first step is to try to draw the tree that's defined by this long expression. So I would suggest pausing the video and taking a moment to try to draw this tree. And then I'm going to show you what it looks like in 3, 2, 1. The way you can draw this tree is to draw the root, label 3, and then look at this list. It's got 3 things in it. Tree -1, tree 1 blah blah blah, and tree 1 blah blah blah. So you draw 3 different nodes that are the branches of the whole tree. Then you can start investigating the structure within them. Okay, back to the task at hand, counting paths. Let's look at this example first. Paths that sum to 7. 3 plus 1 plus 2 plus 1 is 7. So that is a path from the root to this node where all the labels along it sum to 7. So that's 1, but this says there are 2, and that's because 3 plus 1 plus 3 also sums to 7. So we're writing a function that looks through the whole tree, finds these 2 paths which sum to 7 each, and therefore returns 2. Picking this example, paths that sum to 4, we see 3 plus 1 is 4 and 3 plus 1 is 4. These paths do not go all the way to a leaf, but they do start at the root and go to any node, and so they both count. What about paths that sum to 3? Well, there's a really short path that starts at the root and ends there. And then it turns out there's a longer path that extends from there. 3 plus 1 minus 1 is also 3, and so there are 2 paths. What's important here is that just because you found the end of a path does not mean that you're done looking. You might have to continue going because you might get to a longer path that also sums to whatever your total you're looking for. Take a look at what's down here. The first thing you should do is take a look at the recursive case and figure out what you can do there. Ask yourself, when I make a recursive call on each branch, what recursive call should I make, and what do I get back when I do it? How can I use that information in order to return the right value for the whole call? So now's a good time to pause the video and think about it. I'm going to go through the answer in 3, 2, 1. This recursive case says found, and it's supposed to return a number. So found must be a number. And how do you know that you've found a path that sums to total? Well, if the label equals total, then you've found a path that sums to total. And so found should be at least 1, the one you found, plus all of the paths that you find in the branches. So if you didn't find a path that ends at this node, there still could be paths that end in the branches, and so we use recursion to find those. We write, I want the sum of countPaths b for each branch in t.branches. Now, if we want the path sum to be total, and we're looking only through the branch, then we want the sum of the path through the branch to be total minus t.label, so that the path through the whole tree is total. Because every path through t, regardless of which branch it goes through, has t.label as part of it.